Ionization energy, A-level chemistry. Ionization energy. Ionization is the removal of one or more electrons. And ionization energy is this energy that is needed to remove one electron. So the first ionization energy is the energy needed to remove one electron from an atom to give one plus ion. So remember, for any element, there are so many electrons, or there are more than one electron except for hydrogen, which has only one electron. So we can have the first, second, and so on different ionization energy. Each ionization energy represents the energy needed to remove one electron from an atom or from an ion. So let's look at the first ionization energy and how to define it. So first ionization energy, to define first ionization energy, this is the energy needed to remove one electron from each atom and 1 mole of gaseous atoms to give 1 mole of gaseous 1 plus ions. So you start with the element as a gas, and then you end with a 1 plus ion with a gas with the removal of an electron. Remember, for this ionization energy, you have to put the gas symbol and you have to refer to 1 mole for the ionization energy. And this is, as you can see here, this is the delta H here is plus, which means this is an endothermic process. So it needs energy, it takes an energy to remove the electron. Of course, the lower the value of the ionization energy, that means that is easier to remove that electron. Successive ionization energy, as we said, you can remove all the electron from an atom successively. So second ionization energy, to define it, we're going to use the same definition we used for the first ionization energy, but in this case, this is going to be the energy needed to remove one electron from each atom and 1 mole of gaseous 1 plus ion to give 1 mole of gaseous 2 plus ions. So this is the second ionization energy for sodium. So since this is sodium 1 plus as a gas, that gives you sodium 2 plus as a gas and an electron. And this is the value of the ionization energy. Again, we refer to 1 mole. You can write the equation for whatever the nth ionization using this equation. So for any element that is X, so the nth ionization will be X n minus 1 plus as a gas to give you Xn plus as a gas and an electron. So what are the different factors that affect the ionization energy? So if we look at the first and second ionization energy for sodium, for example, you're going to find there is a big difference between those. And if you compare the first ionization energy of different elements, you're going to find the different values for the ionization energy. There are three factors that affect the ionization energy. The first one is the nuclear charge. This means that how many protons are there in the nucleus. So if there are more protons, that means there is more positive charge inside the nucleus. And then this is why there will be a stronger attraction between the outer shell electrons, which are removed during the ionization, and the nucleus. So this is why across the periods in the periodic table, as you can see, as you go from the left to the right, there will be an increase in the ionization energy, because we are referring here to the first ionization energy. So this is because there is an increase in the number of protons as we go in the period from the left to the right, and so there is more positive charge, more attraction. Second factor is the distance from the nucleus. So as expected, as the outer shell electrons become further away from the nucleus, that means less attraction between the positively charged nucleus and the outer shell electrons, so they become easier to remove. So ionization energy will decrease as we go down the group. So down the group, the ionization energy will decrease, or we can say that ionization energy increases as we go up the group, because as you go down the group, the outer shell electrons become further away from the nucleus. And then the shielding. So what is shielding? So if the outer shell electrons are in higher energy shell, that means there are more electrons or more electron shells between the outer shell electron and the nucleus. And because there are a lot of electrons between the outer shell electrons and the nucleus, the increase in the number of these electrons will shield the outer shell electrons from the attractive force of the positively charged nucleus. So the outer shell electrons become less attracted to the nucleus and will be easier to remove, which means that the ionization energy will decrease. Again, along the group on the periodic table, as you go down the group, of course, there will be electrons, outer shell electrons will be in higher energy shell, so that means that will be less attracted to the nucleus, and then they will be easier to remove, so ionization energy will decrease down the group. Electronic shells, structure and ionization energy. We can have the successive ionization energy for any element, and we can calculate the different ionization energy and put that in a graph. So these are the successive ionization energy against the value of the ionization. So when we look at this, we can have information, we can look at the trend and look how the ionization energy changes with the removal of successive electrons. So if we look here, you can see that within each shell, their successive ionization energy will increase because electrons are removed from an increasingly positive ion, because every time you have more less electrons, which means you're going to have more positively charged nucleus compared to the number of electrons. This is an ion now, positively charged ions, which means the electrons in the outer shell will be more attracted to the nucleus. There will be less electrons, so there will be less shielding or less repulsion between the electrons as well. So they will be held more strongly. So this is across the shell. For example, the second shell for sodium, as you can see, there is an increase in the ionization energy as we remove one electron. And then we will notice that there is a jump here. So there are two jumps here. So this is the first jump and this is the second jump in the ionization energy. This jump represents removal of electron from a new or a different energy shell. So when electrons are removed from a new shell, there is a big jump in the ionization energy, as we can see, because electrons are removed from a shell that is closer to the nucleus. So in addition to the fact that it's actually a more positively charged ion, also the energy shell will become even closer, or the electrons in the outer shell outer shell become even closer to the nucleus. So there is a big jump here in the ionization energy. When you look at these graphs, these graphs can give you information about the group the element belongs to. How can we predict the group, or how can we tell what group the element belongs to? We can look at the left side of this graph, and we can count how many points are there before the first jump. So for sodium, for example, this is the successive ionization energy for sodium. You can see that there is only 1 point before the first jump, which means that sodium belongs to group 1. And then we can also have information about the electronic structure. We can get this information if we work on that from the right to the left, and then we start to count how many points are there before each jump. So for example, here you can see there are 2 points. So this is the first energy shell, and then there is the first jump. Okay, so now we're starting with the second shell, and then there is no jump here. There is, of course, as the successive ionization energy increases, the value of the energy increase, the ionization energy increase as well. But there is no jump here. How many electrons here? There are 8. So this is the second shell, which has 8 electrons. And then finally, you're going to find this is the second jump, where there is only one